Okay, let's take a look at our review. We're going to fly through this pretty quickly. So if you miss something that I say, go ahead and pause it, rewind, and re listen. Or if you only need certain parts of your study guide to go over, please fast forward to that section so that you've got it. Okay, so draw the graph of 3 pi over 2 in standard position, including polar axis, terminal side, and the angle. Okay, so when I draw this, this right here is my polar axis. And because it's an axis, it's going to have an arrow. When I look at 3 pi over 2, I can scooch down to your unit circle. 3 pi over 2 is actually right here. So it's the angle going over towards that terminal side. So I'm going to go ahead and draw my terminal side. That terminal side goes right here. And of course, here is our pole. That angle is going to be here. So that's your theta. It takes over 3/4 of our coordinate plane. All right, complete the sentence below. The origin in rectangular coordinates coincides with the pole in polar coordinates. The positive x-axis in rectangular coordinates coincides with the polar axis. Okay, we just talked about those. All right, plot the point with the given polar coordinates 3 pi over 3. Okay, so I'm going to draw my polar axis. And then pi over 3 is 60 degrees. So I think that's about 60. And then I'm going to draw my number line and go up 3. And this would be 3 pi over 3. Just that simple. And here's our angle theta. All right, given the polar coordinates -2 pi over 6, what angle would it be if you wanted to rewrite the coordinate point using +2? So we want 2, but we got to put in an angle. All right, there's an easy way and there's a long way. The easy way is to take a look at that angle that we just talked about, which was pi over 6. Since it's -2, we're going to back it up behind it, so we have 7 pi over 6. So that's the fast and easy way. Oops, 7 pi over 6. The other way you can do it is you take pi over 6 and you add pi. Of course, if this was a degree, let's say it was 60 degrees, then you would add 180 degrees. Well, in order to add fractions, I have to make sure they both have the same denominator. So pi over 6 plus, and this has to be 6 pi over 6. So that will give us 7 pi over 6. So either way, I still get 7 pi over 6. You pick the method that's most comfortable to you and stick with it. All right, graph the point with polar coordinates 1, negative pi over 2, and describe its location. All right, I know that when I graph something, in order to go positive in my angle, it has to go counterclockwise. If I want to go the negative direction, I'm going to go clockwise. So when I have a negative pi over 2, I know that pi over 2 is this axis right here. But that's if it's positive. I'm going negative, so my axis is actually going to be here. So I'm going to graph my terminal side, and I got to put my number line down, and it wants to be 1, right? Because this angle is negative pi over 2. So that dot is 1 negative pi over 2. Okay, so hopefully that makes sense for you. The next one, the point 3 pi over 6 can also be represented by which of the following polar coordinates? Okay, I'm going to look at the positive ones first. So that's going to be A and D. I shouldn't put a check mark there because that's not that's not an answer. Okay, so 5 pi over 6 and negative pi over 6. Let me look at my unit circle. So pi over 6 is right here. And so it said, is 5 pi over 6 the equivalent? No. It is actually reflected across the y-axis. Pi over 6 and negative pi over 6? Nope, that's reflected over the polar axis. So those are not equivalent. So I can get rid of those right away. Get rid of those. So this one's out and this one's out. Okay, now I have negative. So with negative, remember, we're going to back it up. So if this is my angle, if I have a negative number, I'm actually backing it up this direction. So I have 7 pi over 6. So the angle is 7 pi over 6. That works. So that's a good one. And then I look at negative 3, 13 pi over 6. This is actually like one full rotation and then adding pi over 6. So that would be, let's see here. Negative 3, 7 pi over 6. Negative 3. Okay, so this is pi over 6. If this is my angle, and negative 3 should have me over here in this area. They're saying negative 3 and this angle, which is not going to work. You can't just exchange negative 3 and positive 3. So on that one, that is a no. So you only have one option, which is B. 7, the polar coordinates of a point are 3, 3 pi over 2. Find the rectangular coordinates of this point. So I know that my x is equal to r cosine theta, and my y is equal to r sine theta. Let's handle x first. So r is actually 3, because remember this is r theta. So 3 times the cosine of 3 pi over 2. 3 pi over 2 is right here. The cosine of that is my x coordinate, so that's 0. So the cosine of 3 pi over 2, this whole thing is equal to 0. So I have 3 times 0, which is equal to 0. Okay, so I have 0 as my x coordinate. Then I'm going to look at y. 3 sine 3 pi over 2. And again, I'm going to look and see what sine of 3 pi over 2 is. The sine of 3 pi over 2 is this one right here, which is negative 1. Oops. So I'm going to substitute in 3 times negative 1. That gives me negative 3. So I have 0, negative 3. Number 8, the polar coordinates of a point are 5 and 3 pi over 4. Find the rectangular coordinates of this point. It's the same thing we just did. So x is going to equal 5 times the cosine of 3 pi over 4. And y is going to equal 5 times the sine of 3 pi over 4. I know that the cosine of 3 pi over 4 is equal to negative root 2 over 2. Look it up if you need it. The sine of 3 pi over 4 is root 2 over 2. So I'm going to have an x value of 5 times negative root 2 over 2. And I'll just smash that together. So I have negative 5 root 2 over 2. My y, that'll be 5 times root 2 over 2. And again, I'm just going to smash it together. So 5 root 2 over 2 is going to be my y. So my coordinate is going to be negative 5 root 2 over 2 and 5 root 2 over 2. So there we go for 8. Number 9, rectangular coordinates of a point are given. Find the polar coordinates. You guys have been doing this since, I don't know, middle school. So x squared plus y squared equals r squared. We're just using the Pythagorean theorem. but we are relabeling our A and B sides with X and Y, and then our hypotenuse is going to be our R. So I have R is going to equal the square root of X squared plus Y squared. So that's going to be the square root of 6 squared plus 6 root 3 squared. Now when I take I'm just going to keep moving it down here. 6 squared is going to be 36. When I find the square of this is 36. And then when I take the square of the square root of 3, that's just going to be 3. So when I have the square of a root, I'm just going to raise the roof on that. Just take the roof off, and I end up with 3. So that's going to end up giving me, I'll stick it in red, 108, because I'm going to do 36 times 3, and that gives me 108. So then I have the square root of 144, which we know is equal to 12. So R is equal to 12. Now we have to deal with the angle. So our angle, we know the relationship between X and Y, and our angle is going to be the tangent function. So the tangent is going to equal Y over X. Well, to separate that tangent from its angle, we have to take the inverse. So the angle is inverse tangent of Y over X. So let's go ahead and see what that looks like. We're going to have the inverse tangent of 6 root 3 over 6. And that, my friends, will have your 6 cancel out. So it's just the inverse tangent of root 3. I happen to know that root 3 is the tangent of pi over 3. Or it's the tangent of your opposite, right? So pi over 3, which is right here, or it could be 4 pi over 3, depending on what quadrant we're in. Because both of them are positive, then I know it's in my first quadrant, so it's pi over 3. If they were both negative but gave me a positive root 3, then I would know that it's 4 pi over 3. So pi over 3. Well, what if you don't know that it's pi over 3, right? I looked at this and I said, okay, root 3 over 2 over 1/2. My 2's cancel out and I'm left with square root of 3. That's what my tangent is. What you could do is put your calculator into degrees and you could find the inverse tangent of the square root of 3 and you'll end up getting 60 or something very, very close to 60. And then you can also see that 60 is equal to pi over 3. So a couple ways you can do that. So my polar, I guess, I got to put it together, is 12 comma pi over 3. That's my coordinate. The letters X and Y represent rectangular coordinates. Write the given equation using polar coordinates. I'm going to write several correct answers. They all mean the same thing. So X is going to be R cosine theta, and then I'm going to square that quantity. That's going to equal 19 sine theta, R sine theta. Okay, so that is correct. I could also write it, I'm going to put this in a different color. I could do R squared cosine squared theta is equal to 19R sine theta. That's correct. Or you could also put it in the format of, if I got rid of an R from both sides, that would be R cosine squared theta equals 19 sine theta, right? I don't know what benefit you'll get by taking out an R, but it works, right? The other thing that you might see is they want it to all be on one side. So you might see it as R squared cosine squared theta minus 19 R sine theta equals 0. Or again, another version where it's R cosine squared theta minus 19 sine theta equals 0. Okay. Let's take a look at the back side. And the reason why I'm showing you all these is in case on the ACT it shows up and you need to be able to pick it out of a lineup. I'm okay accepting all 3 of these versions. Okay, let's look at number 11. This is actually easier than the previous one. So I have R cosine theta equals 19. So we're done. Or what you can also do is say r cosine theta minus 19 equals 0. Both of them exactly the same. It's just a matter of preference of where you want it. The letters r and theta represent polar coordinates. Write the given equation using rectangular coordinates xy. So we have two options, right? When we see the polar, we can either square both sides, so square both, or we multiply by r. This is typical if we see trig functions. This is if we don't see trig functions. So I don't see a trig function here. So I'm going to square both sides. So r squared equals 12 squared. I also know that r squared is equal to x squared plus y squared. So using the transitive property, I can have x squared plus y squared is equal to 12 squared. Now, interestingly enough, there is no shift in my x and my y. So the center of that circle, this is a circle equation, is 0, 0. And my radius is equal to the square root of 12 squared. And when you have the square root of a square, right, you're just going to raise the roof on that. So you have a 12. So this would actually graph out as a circle. Let's call this 6. Let's call this 12. Let's call this 18. A circle with a center at, I don't know if it's going to, sorry guys, that gave me like an ellipse there. So if I'm going to, how would I draw it first? That might be the way to go. So if I have a circle, there we go, right? The origin is going to be at the center of that circle, and then my radius is going to be 12. So this value is 12. Here's my 6. That might have been the way to go. Just an FYI, this is additional information, but it's good to hear. If you have a shift, so let's say we have x minus 3 squared plus y minus 2 squared equals 9, right? So if I wanted to draw this circle, this negative 3 here, or minus 3, tells me that my center is located at 3 and at 2. So my x shift is 3, my y shift is 2. If it said x plus 3, then my shift would be negative 3. If it said y plus 2, my shift would be negative 2. So there's my center, and then my r is going to be the square root of the answer, which is going to end up being 3. So in this case, I have a circle, and again, I'm going to do it backwards so I can, so this is going to be 3, 2. So, and I have a circle of 3. So this is actually going to be my axis here. Not quite. Not quite. It should be tangent to the circle. My axis is right there. And then my, let's say my axis is like there. Okay. So this would be a radius of 3. And that point right there would have my center at 3, 2. So that's how you deal with shifts. Okay, so that would be 3, 1, and 2. On your test, I am going to have a couple, or quiz, I'm going to have a couple bonus questions. You will be expected to graph a circle for sure, coming from a polar equation. But I may throw on an equation that I give you. I'm not going to do completing the square, but I may throw an equation where I give you something with a shift and you have to graph it. Or I might even, as bonus, put one of those special graphs that we saw, right? All those different ones that we had on that handout. So I told you you could have that handout on your quiz if you needed it. Might be worthwhile to do that. Okay? Any questions? Let me know.